that we had parabolas that were up like a cup or down like a frown?
Yeah.
Well, we also have parabolas that go sideways. We have left and right parabolas. Okay? So what we're going to look at today is how we can define little bits and pieces that happens within all four of these types of parabolas. They're very, very similar in nature, and they all stem from the same stuff. We look like this. Regular old boring x squared parabola, we know up like a cup, right? Today, like I said, we're going to center everything at the origin. Wow. Impressive. What's that point called? The vertex. Yes, the origin.
Oh, that's a good.
Okay. This is our vertex. Okay. Now, can I see your glasses?
Okay, just gonna snap them in half.
Yes, I'm going to stomp on them.
Obviously.
Now, glasses are curved. We agree?
Yeah.
These are parabolas. They're convex, concave, whatever they're called. Concave, yes.
They came in.
They cave in, thank you. What happens here, if you think about it, every one of these are some sort of a parabola. Everybody's prescription is a little bit different. Everybody has something to put away their phone to work on focusing at something, right? Glasses help you to focus. Thank you.
I don't
Curves, parabolas always look at what's called a focus. There's a focus that they look at. Makes sense. When you have glasses, you have to look at something so you can see it clearly. So these curves are always going to open towards a focus. What else that they have is, if you think about how light works, and I know that you guys probably all looked at this before in you're bouncing light off like a mirror, how it goes backwards, or in biology or some class you might have looked at the eye, how your eye has a focus point behind it, it looks forward,
Yeah.
there's things there. What happens here, now somewhere along the line you might have, what's happening is there's a counterbalance to a focus. This counterbalance is called a directrix.
sounds really cool sounding.
I just thought matrix.
Yeah. It's called a directrix. Now, if I'm showing you like this, what kind of a line is the directrix? It's horizontal. Yeah, if you stand sideways, it's horizontal. Sorry, Mike, a little curvy. The directrix is a horizontal line when I'm up like a cup or down like a frown. What is the equation of every single horizontal line? Y equals something. So it's always going to be y equals some number. Okay? Now, what's happening here is that this distance from the vertex to the focus is always the same as the vertex to the directrix. It will always be the same value. And this is where we start to bring in some other terminology. Now, what I want to show you is that all of this information is the exact same if it's down like a frown. The focus is still there, the directrix is still there. All that stuff is the same. Notice how the parabola is just opening downward. It's still opening to the focus. The directrix is still counterbalancing it behind it now. It also does the same thing if it's turning left and right. But what changes? X equals. The only thing that changes then is that your directrix becomes a vertical line.
What's the point of directrix?
It's a counterbalance. Directrix, it's a counterbalance. What happens is it helps you to define how skinny or how fat your curve is going to become, depending upon where your focus is placed. What's that? Directrix? Yes. Okay. So this works the same for opening to the right or opening to the left. What's going to be different here? No, we don't have that. Oops. we get two different styles
Uh-oh.
of equations. What do you mean, uh-oh?
One's like,
Is one gonna be upside down and one's not?
No. We get two formulas.
That's fine.
We're going to have when we're up like a cup or down like a frown, we're going to have an x squared equals 4py. I'll explain what this is in a second.
wait, so this is when the variable is up and down, right?
This is when the parabola is up and down. When it's left and right, like you guys said, the only thing that changes really is instead of the directrix being a y equals, it's now an x equals
So that's y squared equals 4py.
4px. This would be y squared.
Is it defined as direct?
We will, don't worry
No,
about
I don't
it.
know.
I'm getting there. I'm getting there. Take a deep breath, okay? What's happening here is all of our parabolas that we're going to work with have this going on. This value of p is always going to be the distance from your vertex to the focus. If p is positive and it's an x squared, it goes up.
Okay, so if p's negative, then it goes down.
If p is positive, it's up like a cup. If p is negative,
Here's pause.
it's down like a frown.
It looks like you wrote his pause.
Mr. Murphy, what's speed?
The distance between the vertex to your
What's
focus.
speed? How can speed?
Because distance can have different direction.
Ah! Thank you, thank you. I was scared.
Distance is an illusion. Wait, hold on. It's the distance between what?
Vertex
Class has no show.
and focus. Okay. Now, if it's opening left and right and p is positive, which way do you think it's going?
Right.
Correct. If it's a y squared and p is positive again, it's opening to the right. And I'll show you how this works given an example. Yes, ma'am.
So it seems if it's the distance from your head to focus, then you
It is. It's the opposite, and then just go in the other direction. That's right. What she's asking is, it's if my value for p was 2, yeah, you just go in the other direction. All right? So let me show you a very, very easy example to start with. Let's say we have x squared is 12y. And you set these problems up the exact same way every time. First thing you have to decide is if it's an x squared or a y squared parabola. Which one is it?
X squared.
This is x squared, and how did we know that?
It says X squared.
It's that obvious. So what you do is you're going to write down the generic formula for an x squared parabola.
It's an up like a cup.
X squared equals, very good, 4py. All I did there was just wrote it down. Yes, ma'am.
Sorry, I was writing something else down. If P is positive for the side where it's going both ways,
It's like,
Now, what's the coefficient of y? 12 has to equal? Exactly.
So what?
Guys, let me finish the problem before you start yelling what. Okay? Just wait a second. Notice, 4 times something times y. That's all it says. 12 times y. You set those two equal to each other. What's p? 3. So that tells me I know that these things are centered at the origin. My p value is 3, and it's x squared. What direction does this open? Up. This way. Both.
up like,
Everything today is centered at the origin. So my vertex is at 0, 0. There's my vertex. My p value is 3, which means I just go up how many spots? 3. What's the ordered pair?
so these problems are the like we always.
For today, yes, for the 7th time.
No, but why is that? Like, is it not in the equation because it's 0, 0, or like?
There's no h of a.
oh wow.
There's no shift yet. Today, all I'm wanting to do today is explain to you guys the relationship of how you find P and how you can plot it out. When we get to the point of having H and K, you will have we will get to that. Well, right now, H and K are both 0.
Wait, so what exactly does P loves do?
So can two other pair values be negative 3 and 3?
No. Right now, I have a focus. It's at 0, 3. Everybody okay with that?
Yep.
This is my focus. My directrix goes through what? Negative 3. Now, the directrix is a line. What's the equation of that line? Y equals
Negative 3.
There's my directrix. I know it's going to do this. What's the last thing I have to pick? Symmetric twins. I'm going to get symmetric twins. Everybody okay with that? Now, this is where it gets weird. Right now, your generic equation, or your starting equation was x squared equals 12y. Everybody agree with that?
Yeah.
Now, in order for us to get something to make sense of that, we've usually selected a value of x to get us a value of y. Do you agree? Okay. Now, in your calculator, you have a button that says what? Y equals. How do I get y by itself? Okay, divide by 12. So that means it's the same thing as saying 1/12 x squared is y. Do you agree?
Yes.
Can I type that in my calculator? Try it. How come it's what? How do you multiply by 12? Multiply by this?
I did that. My big sense.
Oops. Did 1. Now, what I want you to see is that, yes, you would normally get a whole bunch of crummy looking fractions. Do you agree? What's a number that works cleanly? 6 and? So at my ordered pair then that works cleanly, 6, 3. What would be the symmetric twin? Negative 6, 3. Very good. Remember, symmetric twins are just going to be the same value on either side. So when we're walking through these things, that's what the scenario is. You identify if it's either x squared or y squared. You figure out what the p value is, and you start to walk off distances. Yes, ma'am?
Wait, I don't know if I'm just not thinking right now. So, but okay, 6 and 3.
Yeah.
Would that be over 6 and up 3?
Yes. I
So it
just
should
fleshed
be
it.
even with the.
It should be even with the 3s.
Oh, yeah. I didn't even notice it did that. Sorry. There. Is that better?
Here we go, yeah.
Sorry. I just kind of threw it out there. Like, yeah, whatever. You weren't crazy. Just me. Yes, ma'am.
Can x squared like ever be negative before you like divide it? Like can or no, like can fourth be negative?
Yeah.
Like can the fourth like
I'll show you.
never mind.
I'll show you.
Not quite.
Okay.
How do we do this without calculating?
Same way. You just pick numbers that make sense. You got to know your numbers. Got to know numbers. Now, let's look at one that has a y squared value.
Sure came to bounce.
Bye, Mr. Gonzalez.
See you, Mr. G.
I don't know you.
I'm going to do the same idea with a y squared one. And you guys can see how the same scenario unfolds. You're going to do the same basic steps. So we have two different types of formulas. We have an x squared equals 4py, or y squared equals 4px. These are for the ups and downs, and these are for the lefts and rights. Okay? Now, in order for us to figure out which one it's going to be, we just have to read. Is this an x squared or a y squared? It's y squared, so I know it's going to go either left or right. Which means I want to get y squared by itself. How do I undo multiplying by negative 1/6? Multiply by negative 6.
Yes.
Oh, yeah.
Everybody okay with that?
Yes.
Now, since I've got y squared by its lonely self now, I'm going to write down the very generic formula for y squared. I'm going to write down y squared equals 4px. What do I set equal to 4p? Very good. Negative 6 equals 4p divided by 4. I get negative 3 over 2 as my p value. So now we know that this is a left or right parabola. My p value is negative, so what direction is it going? It's going that way. It's going to the left, correct?
Like the opening.
I know. I'm sitting there looking at you going, this is my right hand, I'm saying left, it's got to go that way. It's fun to stay at the...
Right here. See,
Oh, I did to the wrong direction, didn't I? What?
No, it's fine. At this point, again, where's our vertex?
0,
0, 0. Good. My vertex is at 0, 0. My p value is negative 3 over 2. That means I'm moving to the left to my ordered pair of negative 3 over 2, comma, 0. There's my focus. Where's my directrix then? Positive 3 over 2. What's the equation for it?
Y.
Ah!
Yeah, well, x equals. It's gonna take y. So by the end of the week it'll work. It'll stick by the end. Well, I will have this stick by the end of the week.
Okay? I know it's got to open to the left. Remember, your curve is going to go towards the towards the focus. And what's left?
Your points.
My points. Now, here's where it gets interesting. We have negative 6x equals y squared. I don't have a y squared button on my calculator, do I?
Nope.
Nope. But I have a y equals button. How do I get y equals out of this?
Just square root.
Now, here's where you have to be smart. Can I take the square root of negative 6?
No.
No. So here's what I want to do. I know it's got to open to the left. Do you agree?
Yeah.
So I'm going to take the negative square root of 6x. Put that in your calculator to the table. Negative square root 6x. If I graph that, oh, did I flip the wrong way? It was supposed to be the other way. I typed that in wrong? Oh, I didn't.
Probably,
I think we all did it
subtraction
wrong.
button instead of
I got the same picture.
Mine's up like
It shouldn't have done that. What did I do wrong?
I don't see it at all.
Mine is not up like mine is going that way.
It should be the other way. It's supposed to be going that way. How did I flip that wrong? Oh, I'm an idiot. I'm an idiot. I'm sorry. Watch that. Duh. It is the square root of negative 6 because I'm looking at negative values. If x is negative 1, it becomes 6. I put it on the wrong side. I'm sorry.
Okay.
Put it down the inside, yes. Because watch. I'm an idiot. At least I'm honest.
Oh yeah.
That's fine.
The square root of negative 6x. Because
No, if you go up,
look at the graph.
you get negative 6 equals 6.
That's okay. Guys, here's what's happening. What values of x will this work when x is negative? If x is negative, it works, right? Because what's negative 1 times negative 6? What's negative 2 times negative 6? What's negative 6 times negative 6? See how you're getting positive values. So when x is negative, that's why it works. That's why it's opening that way. I just put the thing on the wrong side by mistake. That's all. Well, what did we do?
Oh, they're the same.
They're the same, and what we did is we only graphed one side because this should have been a plus minus.
Is that never coming to
It is not, and here's the thing. I don't have to put plus minus into the calculator because I'm looking at symmetrical twins. So in this case here, if I know this real easy one to work with, if x was -6, I get +6. Do you agree? Yeah. Because -6 times -6 is 36. The square root of that is 6. Or -6. So the symmetric twin is down there. We did the same exact thing, but I did not do plus minus in my calculator because it was just, it's basically a waste of time to put both of them in. Because then you have to go through your both different sets of tables to figure out what values you're working with. Use the idea that parabolas have symmetrical twins. You know, one point is here, the other one's got to be right below it. They're equidistant from that axis of symmetry. Okay? That's all I'm doing. I'm using numbers that make sense.
Is there any reason why when I went to the table it said error?
What's 1 times -6? What's the square root of -6? There you go. Okay. Let's do one more. No. Same idea.
Okay.
X equals 3/4 y squared.
Times 4.
So when we start out with this, we have x equals 3/4 y squared, which is telling you that it's a y squared parabola. So it's going to go left or right again. I want to get the y squared by itself, so what do I multiply by? 4/3. So now I start with 4/3 x is y squared. Along next to that, I'm going to rewrite y squared equals 4px. Everybody okay with that? All right. What do I set 4p equal to? Good. So I set 4/3 equal, or excuse me, yeah, 4/3 equal to 4p. How do I undo? Divide. Can I say multiply by a 4th? Is that okay?
Yeah.
What's p? 1/3.
Oh, yeah.
So my p value becomes 1/3. This is one of the things why I rarely use calculator by saying divide this 4/3 divided by 4. It takes too long. Multiply by a reciprocal, they drop out right away, get 1/3. Okay? It's just a quick fraction, simplifying fractions. So your p value is positive, so what direction is this going to open? That way. It's going to open to the right. Okay? So we start again. We have our origin is our vertex. My p value is 1/3, so that means my focus is at 1/3, comma 0. Where's my directrix? What equals -1/3? It's x. Because this is left or right, so this has got to be the counterbalance. So x equals -1/3. I know it's got to go this way. So once again, I'm going to try and pick numbers that make sense. I want to pick some value of x. Because if I simplify this out, does everybody agree that's going to be the square root of 4/3 times x? Everybody agree with that?
Yeah.
What's a very easy value of x to make my life simple?
3.
3. If I use x as 3, what's 4/3 times 3? What's the square root of 4? So what's my ordered pair? 3, 2. So my ordered pair is at 3, 2, which means the symmetric twin is at 3, -2. You're picking numbers that are easy to work with. If you couldn't do that in your head, could you put it in y equals? Yeah. You just look at the positive value of it. You'll get the top half of that curve. And just remember that there's a symmetric twin. You don't need to put them both in your calculator to do y equals. And that's how that works. All right?
Wait, how did you get 3 over 2? Oh wait, no, 3 and 2.
I picked a number that's easy. I want to get rid of 4/3 times something to get rid of the fraction. So I choose 3 for x. I picked a number that was easy. I chose x is 3. So I get 2 for y. So that I'm just picking easy numbers. Mental math, guys. The only other thing that's within this right now is if I give you a directrix or I give you a focus point, you can still write the equation.
Because the directrix just gives me a focus point, just reverse everything.
Yeah. So let's say you have a directrix at y equals 2. And I want to write out the equation. If I have a directrix at y equals 2, and I need to decide directions and all that kind of fun stuff, what I want to do is graph it, plot it. Y equals 2, is that a horizontal or vertical line? Horizontal. It's horizontal. Right now, all of our vertices are lying at the origin. So here's my directrix at y equals 2. My directrix? My directrix is at y equals 2. Where's my focus at? -2. So is it going to be opening up or down? It's going to be opening downward, so my ordered pair there would be at 0, -2. So what's my p value then?
P equals
It's -2, very good. Yeah. The p value is always the distance from the vertex to the focus. The distance from the distance to the vertex to the focus, since it's going down, it's -2. So p is -2. We know this is a downward opening one, so is that going to be an x squared or a y squared parabola? X squared. So it's going to be x squared equals 4py, and I know what p is. What's 4 times -2? Possibly, yes. So the equation of that parabola would then be x squared equals -8y. All we're doing here is getting a visual representation of what in the world are you talking about? Well, the directrix is a horizontal line. I plotted it. I knew that the vertex is at the origin. And then I just knew that the focus then is just 2 spots away from it. Yes, there will be times when we'll have more information, moving them around, shifting them around. But we're not there yet, okay? We're not there yet. Last one, if I give you an ordered pair of a focus.
Wait,
What?
we didn't find times.
Didn't need to, I just want to write the equation. This one was just write the equation. Yeah, these are just write the equation given the information. Sorry, just write the equation. If I give you a focus, let's say it's at -6 and 0. If my focus is at -6 and 0, that's -6. My origin is my vertex. What direction is it opening? Opening to the left. So is it x squared or y squared? It's a y squared. What is p equal to in this case? What is it? -6. That value of p is from the center to the focus, vertex to focus. So p is -6. All you gotta do is substitute in.
Is this another just solving the equation?
Just write the equation. Y squared is -24x. You'll start to see the relationship with that p value the more you work with just given directrix or given focus. It's very easy to work with. Okay, it's very easy to work with. What's going to be a little bit weird is that you're not accustomed to solving for y's when you have y squares and solving for x's when you have x squared. That's where it just takes a little bit of time to get used to it. The arithmetic that you're using in this isn't super complex. There's a little twist once in a while. Yes, ma'am?
How come since you're going towards the 0, the distance is 6?
Since the focus is placed here, the p-value is always the distance. I know what you're saying because the negative. It just says it's opening that way. Since it's negative, that means it's going to the left. And you're right, distance is always positive, but our p-value is -6 because it's opening that way. Okay? You're right, though. Yeah, because the distance can never be negative, but it's directionality. The directionality of it is negative.
The director to 6.
Did I make up that word too? Is that a word?
What word?
What are you going to do about it?
Murphy, what you get us homework?
Yep.
Okay.
I want to show you one other scenario that comes out of these. Because I've had this question come up a couple of times already today.
Really?
What?
I want to look at this problem real fast because it's similar. There's been a couple of questions kind of along the same way. In this problem, I'm going to graph and label everything out. Okay? Now, is this an x squared or a y squared problem? It's an x squared. So I got to get x squared by itself. Do you agree?
Yes, sir.
How do I do that?
Add 1 to 1.
Okay. Are we okay with that?
Yeah.
After that, what's my next thing to do?
Right there.
What was it? What?
4p equals 40.
Okay, good. I was hoping you would write this first. X squared equals the 4px,
Oh,
or excuse me, 4py.
Sorry.
But you're right, 4p, you set the 4p equal to 40. So what was p? Good. Everybody okay with that? P is 10?
Yeah.
All right.
Awesome.
P is 10. It's positive. It's x squared. So which direction is it opening? Up. Very good. So we know it's going to be at 10. So it's at 0, 10 is my focus. Where's the directrix? Negative 10. What equals negative 10?
Y.
Y. Very good. What's left that you have to do? Get me a symmetric twin. Now, again, this is where it's a little bit weird. You have x squared equals 40y. One of two things you can do. Try and get substituted numbers that make sense. Or, could you get y by itself and use its table? How do you get y by itself? Divide by 40. Huh. What I'm saying here is you can try and figure out numbers by taking the square root and at x, you substitute and go that way. But it's always easier to get y by itself because you're used to picking a value of x to generate y. So what I'm doing here is I want to get 1/40th x squared is y. I'm just using the fractional amount there because it's sometimes a little bit cleaner. So what I would pick here is what? You can do x squared over 40, that's fine. What I'm thinking of here, though, is I want to get some value of x when I square it. It's divisible by 40. That's going to be kind of weird, but what if I chose x equals 2? What's 2 squared? 4. What's 4 over 40?
110. Yeah.
I'm just picking numbers that are easy to work with. By doing that, it's a simplistic mental math exercise to solve for your symmetric twins. Otherwise, you're going to wind up with, I think, really large numbers that I don't even know how big you have to get them to make it work. 20 and 10. Yeah, because 20 squared is 400. That's right. Opposite of p.
Oh, yeah.
Okay. Let me give you a handful of these to work out through tonight.
Shut up.
Sarah, don't sign me out.
I forgot to write them down. Why won't this load?
I'll tell them right now. Page 20.
It's $2.99. I know it's on $2.99.
$2.99, problem, and do the examples, read them, you're done.
Yeah.
Wait, what page?
Hold on. It's on $2.99. It's these right here.
$2.99.
Oh, I.
Not $2.99. $5.99. Sorry.
Oh, I did $2.99.
Oh, no.
All right. It's on. This is section 10.2. Now, on the website, I created a new tab up on top so you can see it. Okay? I called that secondary tab since we're still in our quadratic unit. I called it 2A. So if you're on the website,
I forgot what this was.
right here where it says Unit 2B, click that, and then the Chapter 10 stuff pops up, okay?
Gotcha.
And there's your stuff, okay?
Is 5 going to be on this test?